Welcome to my class of science. With me here, your teacher, Mr. A+. Okay, so I've come with this topic, moment, and I'm here actually by showing you on how to go about examination questions under this topic. Okay, so let me run you through quickly and see how best we are going to handle these particular questions that we are given. Figure below shows a seesaw balanced with forces as indicated. So the seesaw is this diagram which they are talking about. Okay, so the first point there, the force is 200 newtons. Then this one is the pivot center. Then here we have this point again where we have 150 newtons. Then the other one we have 110 newtons. Okay. Then the distance from the pivot this side is 2 meters. Then the other side for this force we have 2 meters again. Then for this force we have y meters, of which we don't know. It is just represented by a variable. Okay. Then now from there we can continue reading the question. The 200 force is 2 meters from the pivot. They are actually trying to explain what I've already alluded to. From the pivot, the 150 force is y meters from the pivot. And the 110 force is 2 meters from the pivot. That is what is there on the diagram. Okay. So now the first question, which is question A, is saying state the principle of moment. Okay, so here you just have to state the principle of moment. What is it all about? So the principle of moment states that when let me start writing solutions. Will start from here. Let me use this part of the board. So we have A. So the principle of moment states that for a body to be in equilibrium, which is same as balanced. Okay, I've put this one in brackets because the meaning of this, that is equilibrium. So the principle of moment states that for a body to be in equilibrium or balanced, the sum of clockwise moment about n point is equal to the sum of anti-clockwise moment about the same point. Okay, so that is what the principle of moment states. Okay, so the principle of moment states that for a body to be equilibrium, that is balanced, the sum of clockwise moment about any point is equal to the sum of anti-clockwise moment about the same point. So it means you have hammered that one. Simple and straightforward. Then we go to question B. Question B, that calculate the distance y. So now there we are going to come up with the formula for moment. So the moment we say force 1 times distance 1, I mean. So we have force 1. This is force 1. Then its distance is this one. So this one is going to be named the distance from the pivot to the point where the force is exerted is going to be referred as if force 1 times distance 1 is equals to. So when you look at this diagram, this is the center. So it is balanced in terms of distance. Because from here up to there is 2 meters. Then from here up to there also 2 meters. So this is equal. That's why there we are going to say force 1 times distance 1 is equals to, okay, is equals to force 2 times distance. Force 2 is this one, 150 newtons, times distance 2. Then plus, meaning this side we have to add this plus this one is equals to this one, okay? So plus force 3 times distance 3. That is how we are going to find now the value of y. That is the formula we are supposed to employ. Then from there now, let us substitute the values that we are given on the seesaw. So force 1, what is our force 1 is 200 newtons, okay? Then times distance 1 is 2 equals, then force 2 is 150, okay? Then times distance 2, it's y. Here the distance 2 is y, okay? Is y. So we are going to say y plus, then force 3. Force 3 is 110 times distance 3 is from here up to there, which is 2. So you say 2, okay? Then from there, we are going to multiply here. We are going to have 400 because here we are going to have 150y. When we multiply 150 times y, the answer is 150y. Then plus, okay? Then 110 times 2, what is the answer? 110 times 2 is 220, okay? Then from there, we can collect the like terms because this is a simple linear equation. So now we can collect, because we want to find y according to the question. They have told us to calculate the distance y. So meaning, this one will come this side, so we'll have 400. This is positive. When it crosses an equal sign here, it will be minus now, okay? Then equals 150y, okay? Then from there now, we can subtract 400 minus 220. What is the answer? The answer is 180 equals 150y, okay? Then from there, since we want to find the value of y, we are going to divide both sides by 150, okay? 150, then this side 150. Here you say, then y is equals to, this one can go. How many times does 15 go into? Maybe we can look for a number that can go into 18 and 15. Do we have a number? Yes, I'm sure 3 can do there. How many times does 3 go into 18? 6. And how many times does 5 go into 15? Is 5. Okay, so therefore y is equals to 5 into 6 is 1. Remember what? 1. That one we put a 2 there, a point. Then we say remember 1. Then 5 into 10. The answer is 2. Okay. So y is equals to 1.2 meters. We have answered that question. Okay. So quickly now, we can go to the last question, which is C. Okay, C. The question says, find the force X acting upward at the pivot. Okay, so now on this one, when you look at the force which they are talking about is this one, okay? So where it is here, when we talk of moment there is 0 because here the distance is just 0. So whatever force is going to be there when you multiply 0 times any force, you still get a 0. So now, since it is balanced, so meaning the force acting upward is equal to the force acting downward. So what we are going to do is we are going to find the force which is acting downward. Okay. So the force acting downward, we have 200 plus 150 plus 110. Okay. So when you add this, what are you going to have? 200 plus 110. The answer is 310. 310 plus 200 plus 150, you are going to have 350. 350 plus 110, the answer is going to be 460 newtons. Therefore, this is the same force now, which is acting on top as well, because the seesaw that we have is balanced. So X is equals to 460 newtons. Hence, the answer. Okay, so thank you so very much for your attention and for understanding. Don't forget to subscribe to my YouTube channel, Peter Gorge Learning, for more exclusive videos. Thank you for now.